Howdy, IB Math. It is Miss Kosh. I wanted to make a video to encourage you to solve a couple more, or to prove a couple more proofs. But I wanted to start with something that I just think is cool related to Pascal's triangle. So years ago, I would require my students to memorize some of the triples, and I think you've probably seen. What did I do? Hey, there we go. You've probably seen some of these. These are just really helpful anytime you encounter triangles in SAT, ACT, PSAT. It shows up all the time. Anyway, so 22 years ago, I don't know, something like that, I had a student, I still remember her name, Liz Davis, and she put them to a song, and I have taught it over the years ever since. So she would sing 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. And I've carried that on over the years. Okay, so, but there was one thing I discovered or realized, or somebody showed me, I don't remember, but I just think this is super cool. And you can see that in a couple of these triples, and that is that if I take an odd number, so say 3, and I square it, well, 3 squared becomes 9. And then we want to take that number 9 and go take half of 9, which is 4.5, and I want the integers on either side of it. So half of 9 is 4.5. The integers on either side are 4 and 5. Okay, take another odd number, 5, square it. 25. Half of 25 is 12.5. The integers on either side of that are 12 and 13, and that's another triple. The next one, 7. Let's try that again. 7 squared is 49. Half of 49 is 24.5, which means the two integers are 24 and 25. Let's take, those were already on our list, but now you can see them. Let's take another one. Let's take 9. 9 squared is 81. Half of 81 is 40.5. The integers on either side are 40 and 41, and that should also be a Pythagorean triple. I thought that was super cool, and my kids were, when I'd show this to them when we get to right triangles, and they were like, wait, you mean I can do that with anything? And then I said, well, yes, it looks like it. I mean, does it work for even numbers? Not exactly. Like 8, if you square it, that's 64. Half of 64 is 32. But the triple is two numbers that add up to 32. 15 and 17 add up to 32, so it doesn't quite work the same way like that. But I was going through, I was trying to find you a couple more problems to practice, proof problems, and I was in the IB test generator, and I found this one, and I was looking at it, and I realized, wait, this may be exactly what we're talking about. So let's see if I'm right. What was I doing? I was taking a number, so let's say that A equals 3. Then this is not a proof. This is what I joke and call KD math, you know, the Karen Dillard or whatever, the test prep sort of stuff, where pick a number, plug it in, and see what happens. Okay, so if I square that, I get 9. 9 minus 1 is 8 divided by 2. 8 divided by 2 is 4, so then this term, so this would be 3 squared. This becomes 4 squared. So then over here I have 9 plus 1 is 10 divided by 2. So basically, this is taking the plus or minus on either side. So it was, the way that I was doing it was I was saying a squared divided by, take that number, divide it by 2, and then take the integer on either side, and so it was plus or minus 1/2. And you'll notice that's exactly what we're looking at here and here. These two, one of them was the plus, one of them was the minus, and that's how we got the triple. So all of this is a big mess. Go away. Let's see if I can erase all of it without picking up my pencil. I almost did. Okay. It switches back away from the eraser. So IB, here's what I want you to do. I want you to prove this, but I wanted to give you a little like, oh look, isn't this cool? But I don't want to do it for you. I want you to go in and prove this. So show that means you don't get to plug in values. It means that you have to assume you want to manipulate one side and show that it equals the other. Okay. I would probably suggest, well, when we get to trig, you can't cross over and work on the other side, but I will say that it might be easier. My HL kids, I was showing them how we come up with a goal in proof by induction, and it could be that when you prove this, I want you to manipulate one side, but then what you might do is you might get stuck. So then you could go do some scratch work and start manipulating this side. And then when you get to the same thing on this side and this side, then turn around. So say you had, from here you did scratch work and you had to step 1, 2, 3. Well then, and you were working here and you had step 1, 2, 3, 4. Well then, okay, let's call this step A, B, and C. Then what we would do, if you notice that 4 and C matched, then turn around and put B and then A, and then you're done. Does that make sense? Probably not, but anyway, ask me when you see me. Okay, so I want you to work those. Actually, HL and SL, these. Oh, that's not what I wanted to do. Undo. Okay. Work those for me, and then there's also, I want you to, I don't know if this showed up in a different set of practice or whatever, but I wanted to give you a couple more problems to practice, so do this also. All right, work hard, go practice, like, subscribe, comment, all the things. Goodbye.